Welcome back, statisticians, to our next unit in our statistical journey. This unit, we're going to focus on data collection and all of the subtle nuances that encapsulate that experience so we can design studies that will provide us with the best information possible to make the most informed decision. We're going to start off pretty basic, though, talking about differentiating between a population and a sample so that we can identify the type of sampling techniques being utilized and how those sampling techniques might lead to bias in our data collected. We'll know that we've got it when we can describe how to select a simple random sample devoid of bias. As you can see, we're pretty stacked on our vocabulary. So without further ado, let's pop in. All right. Later on in this activity, we're going to revisit this question, but Abraham Wald was a member of the statistical research group at Columbia University during World War II. He was influential in helping the Allies defeat the Nazis due to his use of statistics, more specifically his sampling techniques, where he analyzed the damage that was being done to aircraft that would return from missions to help them determine where they should reinforce the aircraft so that more would return, aka less get shot down. So we'll take a look at what he was able to deduce, and we'll determine where is the best place to, statistically speaking, to reinforce a plane's armor. If you want to learn a little bit more about him, I have these hyperlinks here for your convenience. All right, so to start, we have a census. A census is an official count or survey of every individual in population. You might have heard this when every so often the United States collects their census data to get a good estimation of how many people live in the United States so that they can allocate funding, so on and so forth. So our population, red, is the left-hand side of this graphic. Everybody. This miniature subset we would define to be sample, because trying to collect data on every single individual in the population is most likely not feasible, especially when you have an extremely large data set. So we take a sample, which would be considered a subset of individuals from the population, and then we draw inferences about the population based on the data that we've collected. So let's take a look at some instances where, based on the sampling techniques, there might have been some bias. Many colleges advertise their school by sharing their percent of their graduates who are hired full-time and or pursuing further study. How legitimate are these statistics? And for you as seniors, I'm sure this might be something that's influencing your decision to attend a certain university. So research says that there are 3 good outcomes from community colleges. You can obtain an associate's degree or a trade certificate, transfer to a 4-year university, and acquire a job in your field of study. At Southwest Tennessee Community College, their homepage boasts our overall graduation placement rate is 98.5%, with 91% working in their field of study. Is there any part of this statement that could potentially be misleading and provide some support to justify your claim? Let's establish some dialogue with one another in our class and consider the ways in which this blanket statement could be potentially misleading. Conveniently enough, by law, most college graduation transfer rate data is publicly accessible through the Integrated Post-Secondary Education Data System, located here. So let's take a look. Here is the data for full-time, first-time degree, or certificate-seeking students who enrolled in 2010 and 2011. You should be able to notice that it does not seem like we are bouncing off the walls when it comes to academic success here. For whatever reason, I can't draw causality, but by focusing our sample here, right, Southwest Tennessee Community College, to only consider the outcomes experienced by graduates, we're ignoring the amount of students that didn't successfully graduate and or transfer, right? So what happened? So please make a selection here as to which category seemingly experienced the highest rate of success. that Southwest Tennessee Community College boasts about. Make sure you read through the categories. After making your selection, what conclusions can we draw about those that may not have graduated, and are they significant? So, what we just experienced in the Southwest Tennessee Community College situation is an instance of bias. And bias is a study flaw that leads to an unrepresentative and/or inaccurate estimates. Specifically, when part of the population has a reduced chance of being included in the sample, we deem this undercoverage. I'd like for you to identify, based on the previous situation, what part of the population from Southwest Tennessee Community College was undercovered. Welcome to Rogers State University. Go Hillcats. In a recent report, the university found that 75% of graduates were pursuing another degree or had found full-time employment by their final semester. The same report shows that their response rate to the university's question survey was only 20%. How did the university collect this data? Surveys. The same report, oh, I think I had a typo here, so I'll make sure that's deleted. All right, so keep that in the back of your mind. Okay. How could bias in the sampling method have affected the estimate? So when individuals chosen for a sample don't respond, this would be an instance of non-response bias. Now, to answer our question here on the right-hand side, we do have a little bit of a roadmap or a template that we should follow. So first and foremost, we need to identify the population and the sample. So in this grade, you can say graduates who didn't find post-grad employment may be ashamed, making them less likely to respond in the survey. Right? Graduates, post-grad employment, population, sample. Then we need to explain how the sampled individuals might differ from the general population. And last and most certainly not least, explain how this might lead to an over or underestimate. So to conclude our response, we could finish with, therefore, this sampling method may include a lower proportion of unemployed graduates, graduates being the population, sample being unemployed graduates, than in the full population. This produces an overestimate of the true percentage of all graduates who are actually starting full-time work, right? And once more, if we take a look, we only had 20% of people respond of the 75% of graduates who were pursuing another degree. So that means 80% did not respond. We can't assume them to be all graduates or we can't assume them to be graduates who solely had jobs or graduates who solely did not have jobs. Okay, but that little percentage that responded could be assumed to be a form of bias. Now, we just touched on two, undercoverage and non-response. So when we are tackling these free response questions, we want to make sure that we don't pigeonhole ourselves. If we're unsure of the type of bias, because as you can see before, right, we can have biases that overlap. Don't try to utilize one of the vocab terms. Instead, simply describe the bias, how it arises, and whether it can lead to an under or overestimate. I'm going to provide you some information here that you can fill in the table. The first two rows are going to be your responsibility, since we had just walked through those. But a voluntary response bias occurs when a sample is composed of volunteers who may differ from individuals who don't choose to volunteer. An example of that would be looking at someone's heart rate. Why can't I click in here? So that's why. I'll have to change that. But so this would be in the example situation. You want to study heart rate during exercise. You recruit volunteers to run a mile and then measure their pulse. The few insane people who actually like to run are the ones who volunteer. So quite naturally, they would be healthier on average than population. This type of bias is considered selection bias, same as our non-response and under coverage, right? All of these biases stemmed from our flawed selection technique in soliciting the responses that we had wanted. Now, these bottom two, question wording and self-reported response, would be an issue within the survey itself. So question wording bias would be something as when survey questions are confusing or leading. So something like this would be where you tout off very positive adjectives. Take, for instance, our boy Guy Fieri. Which show do you prefer? Diners, Drive-Ins, and Dives, hosted by the incredibly talented, funny, and interminable Mayor Flavortown, Chef Guy Fieri, or Iron Chef, hosted by the boring Alton Brown. As you can see, the manner in which the question is described, there's an overemphasis on Mr. Fieri's ability to be a host. Self-reported response bias boils down to when individuals inaccurately report their own traits. Take myself, for instance. I consider myself a pretty strong person, but I wouldn't say that I am a bodybuilder. But this would be similar to me reporting that I am able to bench press 350 pounds. While I wish I was able to push that much weight, I am unable to. But obviously, humans are humans and sometimes provide us with inaccurate data. So make sure you enter that into your graphic organizer so that you have a little tip sheet that you can reference moving forward before moving on to. I know that your moral integrity is the highest it could be, and you are feeling the utmost guilt for even possibly contemplating an idea of bias. Well, I will show you how you can absolve yourself of blame and allow you to repent your sins. So to avoid bias, you must randomly sample. Simple random sampling, we abbreviate as SRS, is a sampling method in which every possible group of individuals in the population has an equal chance of being selected. So you just lived through a pandemic that very early on struggled to accurately provide us with a projection of the human beings that had COVID. The city only provided tests to people who showed symptoms. How could that technique, that sampling method, lead to an instance of bias or a misrepresentation of the data? Let's generate some dialogue with your peers before moving on. Now, there is a little bit of a roadmap here as well when performing a simple random sampling. We can assign each individual in the population a number 1 through n, n being the population size. So if we had 1,000 humans, let's say go with that, in our population, we would assign them a number 1 through 1,000. We would then use a random number generator to obtain the sample size that we would like, skipping repeats, right? So if we obtain the number 3 and then we had 3 appear 7 iterations later, we would write 3 again. They're already in the sample size, okay? So let's say we had 1,000 and we wanted to, or we had 10,000 and we only wanted 1,000, right? We would do the random number generator 1,000 times, whatever numbers that we had acquired, that would make up our sample size. And to conclude, we would then sample the individuals whose numbers were generated. So I ask you, right, if you were the person in charge, right, position of influence, position of power, live decision making, how would you implement a simple random sample of 1,000 New York City residents to test for COVID? And we arrive at our skew it with our gentleman, Mr. Abraham Wald. So once more, he decided to help the British Air Force where to put extra armor on their planes and they provided him with charts of bullet holes in the panes that were wounded and fighting but made it back safely. So I've given you some examples below with each dot representing places hit by bullets. So using the sampling techniques, where on the chart would you recommend putting extra armor? After you make your selection, provide a statistical reason utilizing the methodologies that we've spoken about in this video for your selection. And as always, make sure you complete your reflection and synthesis, and I'll see you all together in class.